Hello children, how are you all? Now it's time for us to recollect a little about the types of classification of matter by the modern scientists. What are the two properties which are taken into consideration when matter was classified? What are the two ways in which matter was classified? So we learned that matter was classified by the scientists based on physical properties and chemical properties, right? We have learned what physical properties are, and based on those physical properties of the matter, they have divided the matter into three states, okay? And apart from that, we have also seen two more extra states, right? Okay, so these are the physical states of matter. So this is these states: solid, liquid, gas, then the plasma state, and the Bose-Einstein condensate. So these are matter divided on the basis of their physical properties. Now, how did they classify matter based on the chemical properties? What are the types based on the chemical properties, right? So based on the chemical properties, matter now is classified into two types, that is elements and compounds. Now, what are elements? What are elements? Or what are compounds? So this is what we are going to learn today. So we will not be learning about compounds for this present module, but we'll be talking about what are called elements, what they are made up of, what they eventually try to form, and how important they are. And we have a separate branch which deals with the study of all the elements, because they are elements. Now, what do you mean by elements? What do you mean by elements? Elements. So when you go to the school, children, so where do you join the school? You join in a class which is teaching you the basic, you know. So you learn the alphabets first. A, B, C, D, E. These are all alphabets, English alphabet. Now, why do you learn these alphabets? We learn these alphabets because with these you can make words, and with these words you can form sentences, right? So just like that, chemistry, or study about the chemical nature of chemical behavior of the matter and the various reactions, they depend upon some basic matter, basic pure substances, which are called as elements. So these elements, they undergo what are called chemical reactions. We have learned about chemical changes the previous module, right? So it is the pure substances which are called as elements, and they undergo chemical reactions, and they form another type of pure compounds, pure substances which are called compounds, right? So we talk about elements and compounds here, but we specifically put our mind on what elements are, right? Now we learn, children, what are elements? What are elements? Elements, as we have just learned, they are the basic substances which are undergoing chemical reactions, and they form other types of pure substances called as compounds, right? Now, what is who named or who coined this element? The word element was first given by the famous scientist Robert Boyle, and that was way long back in 1600s. And the next one, Anthony Lavoisier, was the first one who gave the definition for what an element is. What is an element according to him? So an element is a basic substance which involves in chemical reactions and cannot be further divided or so that is you can change them or into other forms. So it just cannot divide or break them into further smaller forms. So that basic matter or material, we call it as element. Okay, children, right. Now, this element, okay, right. It's not, it is a word element, that's true. But there are so many elements, as we have turned. So there are 26 alphabet. Just like that, the total number of elements that have been discovered or that are present on the earth are nearly 118. So you can say these are the alphabet or alphabet of chemistry language. Okay, right. What are these elements? Right. If you name them, there are so many. They are very easy to remember if you have a pattern called as classification, if you know them. Right. And so these are all incorporated in periodic table, and that you need to refer to always if you are a student of chemistry. Right. But we'll get into these details now, children. What are the types of elements now? The types of elements. How many types of elements are there? Within the elements, there are three groups of elements. First one, they are called the metals. The second group we call it as non-metals. And the third group we call it as metalloids. Now, what are metals? Which metals, which elements do you call as metals? Okay, right. There should be some distinctive properties of metals. Now, what are they? Right. Okay, just name one metal if I ask you. So you surely jump up and say gold, because that's something very common to us. So we talk about it. The next one, copper, right? Aluminium. We'll be using all these things, these metals. Iron, they are very well-known element to us. And that iron. Now, what are these? I call them as metals. Sir, if you ask me, what is that you have classified them into metals? So, okay, right. When I carefully observe these metals, I find that these metals, they have the first property of being lustrous, shining. They have that shining surface. When you cut it, you'll get a very shining surface. It will be silvery gray, otherwise golden yellow in color. That's the first thing, lustrous nature. Then anything else? Yes, they are very good conductors of heat and electricity. Now, this is our common observation. Right, we don't cook in wooden vessels. Right, we may cook in earthen pottery, but you see, children, now these days we don't use them. Instead, we are using stainless steel or copper vessels or aluminum vessels. So these are the vessels. Why? They are very good conductors of heat and what did I say? Electricity. Now, sir, what is this electricity? Well, you know the electric current. Now, you know well that if I pass electric current through a plastic wire. All right, okay. So if I take a plastic pen and put it into the socket, what will happen? Will you get a shock? No. Our common observation is you won't get a shock, right? But will you dare keep an iron nail inside the socket, electrical socket? Impossible. Don't try to do it. It's dangerous. Okay, it'll give a life shock. Right? Okay. So what is the reason that you are afraid of keeping anything? And if you open up a wire, an electrical wire, and see, you find strands of copper in them or aluminum. What are all these? These are all metals. Why? Why do we use those metals only for that? Because they conduct. They allow electric current to pass. That's why we use them. Okay, so they are called as good conductors of heat and electricity. The next one, right? What else? Now, have you observed one thing? If you drop a plate, how does it sound? Now, give a ringing sound, is it not? Bells, made of brass, bronze, these bells, what do? If you strike, they'll gong and they'll ring your ears. So all the bells, okay? The next one, the plates, when they fall, when they're struck, they'll produce a characteristic ringing sound. So that ringing sound is the characteristic of metals. So these elements are metals. So they are lustrous. 1, they are good conductors of heat and electricity. 2, and then what is the next thing, children? What is the next thing? Just now, sonority. And now, okay, when I open the wire, the connecting wire, and see, They're very fine strands of wire, strands, thin strands. So what is that? Metal was beaten into or pulled into, drawn into those thin wires. This ability of the metals to be drawn into wires, that is called as ductility. Duct means pipe. Ductility means ability to be drawn like pipes, wires. Okay. Now, where do you eat, children? You eat in a plate, is it not? The metals, they can be beaten so thin and made flat and can be utilized. So this is the property of metals. This property of metals to be beaten into sheets, that is called as malleability. Ability of a metal to be beaten into thin sheets. Mallet means a hammer. Using a hammer, you beat a metal and become thin. It will not break. It will not become powder. Okay, children, that is about the malleability of metals. Anything else? Anything else about metals further? Yes? Okay, right. So, we have seen about the properties of metals. First one, they are lustrous. Second, good conductors of heat and electricity. Third, sonority. They give their characteristic ringing sound. The next one, malleability, ductility, and anything else. Anything else. Right. So these are the important properties of metals. Now, name some metals. Okay, already we have seen metals like gold, silver, copper. Very good. Next, anything else? Yes. You find some metals which are not as strong as these. Hardness also is a property of metals, but there are some metals like sodium, potassium. They are not very strong. You can just cut them with a knife. So soft they are. Then why do you call them as metals? So there is no guarantee that a metal should show all the properties. So there may be just a deviation in a few properties, but still, most important property of a metal is conductivity of electricity. Right? So that is the chief characteristic, you can say. Conductivity of heat. And there are some more chemical characters which determine metals. Not only these are the physical properties. When we get into the chemical properties of the metals, they behave all same. Right? For example, I'll tell you, metals, most of them, when they are reacting with acids, they produce hydrogen gas. So almost all metals, they produce hydrogen gas with sulfuric acid or hydrochloric acids. So that's the chief characteristic, chemical nature, right? So outward properties. Now, sodium and potassium, they are so soft that you can easily cut that like wax. Okay, right, this is it. Now, there is one metal which is used in thermometers. Come on, tell what it is. Yes? Yes, that is correct. Mercury is the metal which is liquid at what? Room temperature. Sir, why are you talking about room temperature? What's the need? We know well that temperature determines the state. So all metals at room temperature, they are solids except mercury. So mercury is an exception. Right, so these are about metals. Now, let us talk about non-metals. Okay, right, I just forgot this thing. Okay, right, the total number of metals among the 118 elements, there are 92 metals. And we now talk about non-metals. Now, what are non-metals? Non-metals, they are not metals. That means they are not metals because they are not having the characteristics of metals. Now, what do they have? Then what are the characteristics? Quite opposite characters to those of metals. So what are the characteristics of non-metals? So they usually are in the form of powders or gases. Okay, and one of them is a liquid, that is bromine. Then next, now what are most of the non-metals? They usually are colored gases or powders. Okay, right. So you name some non-metals now. Okay, if we name some non-metals like gaseous non-metals, oxygen, hydrogen, nitrogen, fluorine, okay, fluorine, etc. So these are all gaseous non-metals. And do we have any solid non-metals? Yes, we have sulfur. The next one we have phosphorus. Okay, right. So these are, what are they, children? We can also name carbon, right? So these, they are non-metals which are solid at room temperature, right? Now, how many are these non-metals? In the 118 elements that are known present, how many are non-metals? So for your information, it is 20 of them are non-metals. Right, now we'll see what made them non-metals. What are the properties of non-metals? Okay, right. 1. They are not good conductors of heat and electricity. Of course, there's one exception, graphite. It's a very good conductor of electricity. That's made of carbon inside. Okay, that's it. That's an exception. They are non-sonorous. Non-sonorous, if they don't make any sound. Take a piece of coal, drop it, it will break. It's not hard as metals. It will break, it will become powdery otherwise. What is the reason? It's not hard. And second thing is, you don't hear that characteristic clanging sound of or ringing sound produced by metal. So that is non-sonorous. Now if you take any of the non-metals and check, they won't usually be shining. Okay, the surface is not shiny, they'll be dull. Okay, right. And you take a piece of coal and try to break it, it will not become flat, instead it will become broken into pieces. So that is, they are non-malleable. Strike with hammer, they will become powder, they will not become flat. So they are non-malleable. Can we draw these non-metals into wires? Try to do it. It's impossible for you to do or draw non-metals into wires. So that means they are non-ductile too. Okay, right. So children, these are the properties of what are called non-metals. So we have named some non-metals. Again, we'll just recollect what we have named. 1, chlorine, fluorine. The next one, iodine. The next one, carbon, phosphorus, sulfur, oxygen, nitrogen. So these are, right. So they are non-metals. 20 of them. Next one, we have the third group of elements. What are they? Metalloids. What are metalloids? So these are like cat on the wall. Now you say, so if somebody is neither here nor there, but under conditions he'll be here, and certain favorable conditions will be here. So depending upon the conditions, these elements, which are called metalloids, they'll behave as metals, and under certain conditions they'll behave as non-metals. So they have both the characters of metals and non-metals. So now name some metalloids. These are called metalloids, and name some metalloids. So children, overall there are nearly 6 of them. So that makes up total 118 elements. 92 plus 20 plus 6. That's good. Now next one, we have what are the metalloids? Boron, silicon, germanium. Okay, and some more of them. Right, what are they? They're all called as metalloids. Why are they called metalloids? The reason is because they have the properties between metals and non-metals. Okay children, the known elements that we have, 118, are them, out of them, though there are some naturally occurring elements and some of them man-made. For your information, there are some elements which are naturally occurring, they are man-made. Now how did man make metals? There's some information which if you know, it's okay. Right, now that is, there are what are called radioactive transformations or transmutations, we call them. During these, okay, right, so they use some of the elements, naturally occurring elements, and bombard them. We call them as bombard them with certain other very fine particles of matter. Okay, and they produce new elements. So children, there are also man-made elements. Okay, right. So with all these children, we conclude about elements. So we have learned, right, pure substances, they are divided into 2 types. What are they? Elements and compounds. Elements are basic. They cannot be further changed or broken into what are called as further substances, which are what I call them as a step down to them. You just can't divide them further, degrade them by any chemical reaction. Now next one, right? Okay, that is elements. Now elements further are divided into three types: metals, non-metals, and metalloids. Okay, so we have seen the total number of elements: 118, 92, 20, and 6. Good, we have finished that. Right, next one, we have seen the characteristics of metals. Okay, then we have seen the characteristics of non-metals. What are metalloids? We have seen some examples for each of these. So children, hope you have enjoyed this part of the lesson, and if you want to learn more about it, just Google through and find out some more things about metals and interesting things about non-metals and metalloids. And for your information, the metalloids that we are talking, though they are 6, they are a very, very important part of our electronics, like silicon, okay, the germanium. They are so important in making what are called as diodes, transistors, and so many of the microchips and the processing circuits and all these things, and they are all employed in what are called as computers. Okay, right? So children, they are not unimportant. They are important. Some of the metals, now most of the metals we know very well they are important. And non-metals, how are they important? Yes, oxygen. Yes, oxygen is very important for us, right? Oxygen is necessary for us. So just like that, there are importances of all of these. Every pure substance, that is every element, is necessary for us. So children, thank you very much.